I think Gemini is very exciting. It's a multimodal model. If you take a look at some of the demo videos, it interleaves text, image, video reasoning, audio. And one of the exciting aspects is the multimodality, and the other aspect seems to be that the latency is pretty fast. I think what's exciting to me is not necessarily whether it completely outperforms GPT-4. Right now, what I've seen is it seems to have like some incremental improvement, but not necessarily like a huge step change. If you think about it, RAG is basically prompt engineering because you're basically figuring out a way to put context into the prompt. It's just a programmatic way of prompt engineering. If we think RAG will get better, then that we could see that as a way of prompt engineering. It's a way of prompting so that you actually get back some context.
This is Louis-François for the What's AI podcast, and in this episode, I receive Jerry Liu, co-founder and CEO of LlamaIndex. LlamaIndex is in the center of the RAG industry, which stands for Retrieval Augmented Generation, basically combining large language models with your own data. In this interview, we talk a lot about RAG and LLMs. Jerry shares a lot of really applicable insights on how to improve your current RAG or LLM system. I'm sure you'll take out a lot from this episode. If you enjoy it, please don't forget to share it with friends and leave a 5-star review or a like depending on where you are listening this episode. Let's dive right into it.
Hey everyone, my name is Jerry. I'm the co-founder and CEO of LlamaIndex. For those of you who don't know, LlamaIndex is a data framework and platform to help you build LLM applications over your data. I'm really excited to be here. Thanks for the invite.
Of course, thanks for you to be here. And before we get into LlamaIndex and all the cool topics, could you share a bit more about when and how did you get into the AI space?
Yeah, so I've basically been in the AI space for most of my working career. So I graduated in 2017. At the time, I was playing around with the initial iterations of generative models. At the time, it was around GANs. So generative adversarial networks, for those listeners that are aware. At the time, they were pretty basic. And I remember being really wowed by the fact that, you could basically generate bedrooms or just these 64 by 64 renditions of bedrooms using these very basic models. And so I did some basic deep learning research to try to train some of our own GANs, extended it to a 3D setting. And that kind of got me into the whole AI space as a whole, right? And it's very broad. There's the application like ML engineering space. There's the data science aspects, there's pure ML research, and of course, there's kind of like the ML ops like tooling to support the practitioners. So I've kind of dipped my toes in pretty much all three of these spaces throughout my working experiences. But I didn't actually play around with LLMs until around this time last year, back in October of 2022, when I was just starting to dabble around with the GPT-3 API to explore the capabilities. I understood how generative models worked from the theoretical, like kind of conceptual side of things, but I hadn't really explored the full application potential. And so at the time, I was just trying to hack around on some applications using GPT-3. And that's when I discovered the need to basically have some tooling and abstractions to build LLM apps on my own data. I was trying to figure out how to feed my own data into like GPT-3. And that's basically what kind of kicked off the whole inspiration for this project.
And going back a little, why did you choose to directly go into the industry, for example, after your degree, instead of like master's, PhD, or do AI research, like productizing instead of research?
That's a good question. I don't think anyone's actually asked me that. And to be honest, I think I actually did consider going back to grad school for kind of like a master's PhD. I'm a bit of a weird case where, like, honestly, most people, like if you are really into research, a lot of people around that time started applying to these like residency programs and then going to PhDs at these different grad schools. Whereas like if you kind of knew you didn't actually want to do research, you stayed mostly in engineering. So you're an ML engineer or working in an applied field. I liked both. So actually, I applied to the residency program. I was an Uber AI resident from 2018 to 2019. That's actually how I met my current co-founder, Simon. So I did research for about a year, and then that extended to 2 years under Raquel, who now heads Wabi, who was the head of research at Uber R&D in Toronto, working on self-driving cars. And so I did have like a solid stint where I worked on deep learning research, and I was deciding whether or not I wanted to continue this at grad school. But at the same time, I think the other direction pulling me back is I fundamentally really enjoy hacking on things and thinking about how to build products. And so that, I mean, you can kind of see flavors of that in what we do today, but that also motivated me to join an ML ops startup after my research.
Yeah. I guess you love the more applied way of learning as well. And just like, yeah, you basically learn to apply, I guess, just like I do. And so you mentioned GANs, and I'm sure you understand the basics well. I will have like two sides of the questions. On first, for example, for working with large language models and the recent AI systems, what is your thought on the necessity or utility of understanding how transformers work? And the second part is it important to understand also the basics? Like you mentioned GANs, but also the other like more basic neural networks and math behind the models. Do you think this is necessary? Is it useful? Is it useless?
I think it's kind of like understanding computer architecture. I don't think anybody really understands how a computer works under the hood unless you majored in, got a PhD in electrical engineering, right? And you directly work on kind of like the transistors. I think people are going to understand these things at different levels of abstraction. And there's basically infinite depth in ML. I actually think even if you look at the subset of PhD researchers in machine learning, I don't think any of them fully understand or all of them fully understand the theoretical math, right? Unless you're directly working in theoretical ML. So I do think it's just impossible for everyone to understand everything. I think realistically, though, I would say if you're, for instance, like an AI engineer working on applied LLMs, you do kind of need to have the user experience of playing around with stuff like ChatGPT, understand the overall application frameworks of, for instance, retrieval augmented generation agents, like what like types of application use cases are emerging from these models, even if you don't like fully grok the models themselves. And I think you also need to like kind of learn some best practices. We can talk about this too, but like I do think most AI engineers these days, at least, probably should have an understanding of evaluation and how to really benchmark things against a data set for stochastic systems, at least right now. And who knows what will happen when they get better. And of course, like once you get, if you really want to get deeper into AI so that you can try fine tuning models, so that you can try building your own models to kind of learn that additional layer, then yeah, I think learning some of the basics around, how these models work, how, basic kind of like math stats, like backpropagation, those things are all helpful.
And I wanted to dive into that a bit later in the podcast, but while we are talking about this, what would be right now or in the near future the useful tech stack to learn to get into the field? For example, someone that is in another field or currently like a college student or whatever, and they don't have a programming or any background whatsoever in artificial intelligence related space, but they are super intrigued by LLMs and they want to build like an app or they want to work in this field. What would be your recommendation on what they should learn, and how would you recommend them to learn this?
Yeah, so I'm kind of starting off with the assumption that this person at least kind of knows how to program, because if you don't know how to program, there's like a different flow. But if you at least somewhat know how to program, whether in Python or TypeScript or Java even, right, you can at least learn kind of the basics of and so what are the basics? One is choose a large language model. The easiest to start off with is probably OpenAI, so that you can just get an API key and you can start like using it, feed in some input, get back some output, allocate a budget for yourself so you don't like blow the monthly limit, right? Like so you don't accidentally use GPT-4 like and rack up a huge bill. And then the next step is to pick a data source, or basically pick a use case actually, but for a data source. Figure out what you actually want to do. Is it like you want to answer questions over your documents, over your class notes, over your database? Is it that you want to actually kind of send messages, right? Or build a personalized chatbot with conversation memory? And from there, learn some of the basic concepts of RAG, so retrieval augmented generation, as well as agents, as well as like how these general models work. And so those for those, like I would basically, recommend a framework like LlamaIndex. We have a bunch of educational resources on this for both beginner to advanced users. And then for vector databases or just like storage systems in general, I think that stuff comes into play if you actually have like more data requirements, right? And obviously that's kind of at the core of what we do. But just like practically speaking, if you find yourself wanting to try to understand like a large corpus of data, then you should pick like a storage tool, like a vector database. These days, there's a lot of vector databases out there. So you have a lot of choices. You can probably pick one to start with. Or honestly, for LlamaIndex, you can just use our very simple in-memory one. That's not scalable, but just works out of the box. So you can try that too if you want.
I definitely want to talk about RAG, as you mentioned. But first, maybe it would be most useful to dive a bit more into LlamaIndex, just because I think it's an amazing tool. And I would like to demystify a bit for the people that don't know much about it, or like are just unsure of if they should be using LlamaIndex or LangChain or their own thing or whatever. So first, could you share, in your personal opinion, when should one use LlamaIndex and who should be using it? Is it for programmers or for like who is it for, and when should we use it?
Yeah, definitely. So LlamaIndex is a developer tool. So it's oriented towards at least programmers right now, at least, and we'll kind of maybe see what to do in the future. But it's basically at a very basic level, it's a Python package as well as a TypeScript package. So you pip install or npm install package. And the main goal that we have right now is to provide the tools to make it easier for developers to build LLM applications over your data. And so if you have some data source and you want to build some sort of knowledge augmented chatbot over it so that you can ask questions over your data, get back answers, you can use LlamaIndex. LlamaIndex is very broad right now. And so basically any LLM application you want to build, you can basically build with LlamaIndex, right? The main reason I say kind of LLM applications of your data is that's kind of been a core focus of what we of the company basically for the past few months. So basically this includes stuff like RAG, like building some sort of chatbot over your data. This includes stuff like structured data extraction. This includes like talking to your SQL database if you want to run like structured analytics. These are pretty popular use cases within the enterprise. If you want to do summarization, you can also build random cool stuff like just agent simulations, for instance, or kind of like auto GPT like experiences where you can have a conversation with this like chatbot and kind of maintain conversation history. We haven't invested as many efforts there in terms of like first class, like in terms of just like higher level abstractions, but you can certainly build it. And so maybe one thing people think about is when to use LlamaIndex or just call the OpenAI API yourself or write your own tooling. It really depends on how much time you have. And I think time is kind of like a valuable commodity these days. Like I think it just requires more boilerplate for you to set up a lot of these abstractions and make them robust versus using some of our stuff. And we also have a lot of educational materials, right, within our modules to show when to use certain modules for which use cases for both like simple to advanced applications.
Could you quickly share either the differences or your advantages compared to, for instance, LangChain or training from scratch, not training, but building it from scratch, as you said. And lastly, the recent OpenAI assistance, like when should one use LlamaIndex, or what's the particularity or advantage of using LlamaIndex instead of all of those?
Yeah, I think I touched briefly on the building your own from scratch. And as to differences between LlamaIndex and LangChain, this is a very popular question. I think, we're both frameworks. At the end of the day, you can basically build whatever you want in either framework. I would say LangChain has invested a bit more broadly in just a variety of different things. I think we've been pretty focused specifically on tooling abstractions for building kind of stuff around your data. And one of the most popular frameworks is probably RAG. And the way we think about a lot of these abstractions is how are they just extensions on top of RAG to basically provide even more advanced like search analytics over your data. So this includes chatbots. When we think about agents, we typically think about it in the data analysis use case. And so we try to make our abstractions both like very customizable for the advanced user, but also very out of the box and easy to use for the more beginner user. And so that's kind of our main focus and how we think about the differences there. As for the Assistance API from OpenAI, it's good. I mean, I think they've released a lot of features during Dev Day, which I'm sure you might ask me more about in just a bit. But on the Assistance API specifically, what it is, right, for listeners is it's basically like a hosted agent-like experience that's capable of in-house retrieval and code interpreter, as well as function calling for any tools that you pass in. I actually think it's pretty complementary because in the end, what we really want to focus on is really good search retrieval experiences over your data. And we actually have an Assistance API wrapper that's an agent, and we demonstrate that you should really just use LlamaIndex RAG pipelines as tools within this Assistance API. So to have the Assistance API do function calling on top of stuff that you built with LlamaIndex. So use LlamaIndex for instance, index your data, right? Your diverse data corpuses. Their own retrieval API right now is quite basic. I would not recommend it for anything more than a toy data use case. And so, use the capabilities that we have to offer over your data, plug it into the assistance API, the agent, and see what happens.
I assume another advantage is also that you can, yes, use OpenAI APIs to do whatever, but also it crashes sometimes and even often. And so you can definitely not easily, but you can, like, if your query to the OpenAI API crashes, you can also ask another language model, either your own or like Claude or whichever. So I guess that's also quite beneficial from using something external as OpenAI as LlamaIndex.
Yeah, exactly. So in general, there's the broader point about what's the point of LlamaIndex if OpenAI is releasing all this stuff, and so just to address that, basically, as you said, the space is very competitive. Gemini just released as of the time of this recording, right? And so and then of course there's a lot of competition on the open source space as well. And so what we've seen from a lot of users is they want choice and they want good trade-offs. And so they want to have, not have vendor lock-in so that they can pick and choose, maybe plug in some open source model with OpenAI for different use cases. And frameworks allow you to basically just do that very easily and save you time in actually trying out these different abstractions.
You mentioned Gemini, and I actually wanted to also talk with you about that because you recently posted something about Gemini, sharing insights and your thoughts. I would love to know what are your thoughts on Gemini. Do you think this is a big thing, or it won't even compete with GPT-4? I've seen that they haven't even released the bigger model, Turbo, or I don't remember the name, but they haven't released the bigger model yet. So yeah, what are your thoughts on Gemini?
Yeah, so just for some quick context, I know about as much as you do because my tweet was literally just from reading the blog post. But I think Gemini, in principle, from reading the blog post, is very exciting. It's a multimodal model from what they released. If you take a look at some of the demo videos, it interleaves text, image, video reasoning, audio. And one of the exciting aspects is the multimodality, and the other aspect seems to be that the latency is pretty fast. I think what's exciting to me is not necessarily whether it completely outperforms GPT-4. Right now, what I've seen is it seems to have like some incremental improvement, but not necessarily like a huge step change on kind of like the pure text-based reasoning aspects. What's exciting to me is making multimodal stuff practical and easy to use. These days, when you build multimodal apps, you stitch together a bunch of very disparate components that are not end-to-end optimized. You stitch together like an LLM, like a GPT. You add like a text-to-speech service, right? And then a speech-to-text service. And then you use that to try to like bounce conversations back and forth. A big issue in a lot of these applications, not just audio, but also image and video, is latency and speed and actually making sure you have some good end-to-end pipeline. So I think if Gemini can actually be a universal model that can process and crunch a lot of data very quickly, I think it has a lot of exciting potential for basically kind of more advanced RAG use cases, right? And I think that's something that we're pretty excited about, but also, in general, agentic use cases too. So RAG use cases include stuff like being able to crunch like charts, tables within a document, being able to process websites and do structured data extraction better than just pure text processing. We're also excited about, for instance, like being able to kind of do some sort of augmented sensor captioning, like given a video, you can just like generate a bunch of text, right, and have a conversation, but also kind of have a like just also be able to like index your own internal knowledge corpus. And so the stuff you index is not just text data, but also like image, video, audio data, and those things. I do think this will probably become a bigger piece in the future. So far, what we've seen with, I think open source models and GPT-4V have already made a decent amount of advancements in this space, but there's still some like gaps to make this like fully applicable in the production side.
Yeah. And right now, how do you deal with multimodalities and like images, tables, PDFs, everything? How do you deal with that at LlamaIndex?
So pre-multimodal models, the multimodal piece we're still exploring actually. And so that's kind of a work in progress. And Gemini will help accelerate some of that too. The main issue, by the way, with playing around with current models as of the time of this recording is a lot of them are either a little slow to use or they're heavily rate limited, like GPT-4V. So generally speaking, processing a complex document is quite interesting to us. And we've actually posted a lot about this in the past. How do you, for instance, process like an embedded table within a PDF? Like if you have a SEC 10K filing, an archive research paper, any sort of legal brief, like you have a bunch of like charts, tables, right? And you want to somehow index that along with text. And so we have a lot of abstractions within LlamaIndex that basically allow you to kind of like hierarchically summarize and model this this entire document, not just as like a flat list of text chunks, but actually kind of like a document graph. So you have an entire graph of like node objects that link to other node objects. And when you do retrieval, you don't do retrieval just on like a flat top K of like the document text chunks. You actually do retrieval over this document graph. And this allows you to basically query and understand different objects representations within this data. So for instance, for tables, you don't necessarily need a image screenshot of it. You could use like a text parser, right? And then kind of clean that up or model it like a CSV or a data frame. For charts, it's a little bit more tricky. There's a lot of like OCR models right now on charts, and some of them are pretty interesting. But I think there's still a gap in really understanding some of the complex stuff. And so maybe this is something that multimodal models will help with.
Yeah, I hope so. Yeah, we are also facing lots of challenge with like the different PDFs. I guess that's an ongoing problem for as long as PDFs exist. But yeah, really cool. I definitely hope Gemini will help for that, or just other multimodal models. Would you have any tips for companies or individuals to ensure that they have good documentation and like good communication skills?
I feel like our documentation has historically been not that great. A lot of this honestly was from our VP of Developer Relations, Lori. And so he basically came in and revamped the documentation. Actually, again, as of the time of this recording, we're going through like another revamp to try to, add more resources. We've added more stuff and to try to rearrange some of the sections to make it a bit more clear. I think in general, I'd probably kind of think about the audience. And I think for us, again, this is from the context that the documentation has historically been not great, right? And so I think what the audience that we really tried to cater to is the fact that for the vast majority of developers, they're still onboarding onto the concepts. And so they want to see the documentation as an educational resource that supports them throughout their developer journey. I, for instance, am not the target user of the first 70% of the documentation because I already know the modules, the abstractions. I would go straight into the API reference as well as some of the module guides, just copy and paste reference code. But for the vast majority of users, we wanted to frame the documentation such that it was a journey from your beginner in RAG, you're just starting out, you go through the quick start, to you're actually trying to build like a full stack RAG application. What are the things that you try to set up? Here's agents. Like, how do you think about that? And how does that factor into this experience? To now you're trying to optimize this entire system. What are strategies, tips, and tricks you can do that? And so I think that really did help a lot because it basically made it so that the documentation was a lot more accessible so that you could just read through top to bottom.
So I assume it's just like, in my case, creating videos, you need a good storyline. And even if you are just explaining something, it follows a story from an introduction to development and etc. So it's kind of the same thing to have better documentation.
Right, exactly. I think that's a key principle.
Nice. I think that's something I've never heard about, documenting your code. It's really cool. And I hope to see that more in the future for other people.
Yeah, and for the audience, by the way, we're always improving it. I actually don't think the documentation is perfect. There's definitely things that are missing or could be improved. So if you have feedback, please let us know.
Perfect. Now, I'd love to dive more into the Retrieval Augmented Generation, since that's a big part of what you're doing. And first, you already explained what it was, but could you share your insights on why is this so hyped and so popular? Like, why do everyone wants to do Retrieval Augmented Generation instead of other alternatives? Just for example, as fine-tuning, where you retrain a powerful model on your personal data. Why why is RAG so popular now?
I think that's a good question. I think first, maybe I'll explain what retrieval augmented generation is, and then I'll talk a little bit about why it's probably the main enterprise use case these days, and there's probably a reason for that. So what is retrieval augmented generation, or RAG for short? So RAG basically means that you fix the model. The model doesn't change. You're not training it anymore. It's already pre-trained. You're just using the OpenAI API out of the box, or Llama 2 or whatever. And then you take some data corpus, right? And RAG is just a way you combine the two. So the way it works is you load in some data from your data corpus. It could be PDFs, databases, CSV files. Okay, actually, not CSV files. Forget about that. But like some sort of like semi-structured, unstructured data. And then you want to index it. And typically you index it into a vector database. So you take in some of these documents, chunk it up, embed them, put them into a vector database. And then now that the data is in your storage system, you can basically build this RAG pipeline where, given a user query, you first retrieve the relevant context from the vector database. And vector databases expose an endpoint where you can basically fetch the most similar documents given a user query. And then you take this like text and then you stuff it into the prompt. So, just imagine a giant text string. There's some room in the middle. You take all that text and just dump the documents as plain text into the input prompt. And this is the thing that you use to basically generate an answer. So the prompt template looks something like, here's some context, dump the context in. Here's the question, dump the question in, and then you get the answer. That's RAG. And you can honestly replicate this experience by just opening up ChatGPT in your browser and just taking some random web page or article that you see and copying and pasting a text, put it in ChatGPT and ask it to summarize stuff for you, right? For anyone using ChatGPT, like people do this all the time. That's basically RAG, which is automated, right, in some sort of like systematic setting. And so why is this so popular? One, because it's a core use case for search and retrieval. I think the time, so one, it's a very valuable use case. I think we've talked to a lot of companies. A lot of them see a lot of value in being able to extract insights from their kind of unstructured data in a performant, fast, and cheap way. Two, it's really easy to set up. In LlamaIndex, you can get something working, the basics, in 5 lines of code, right? You don't need a training data set. You don't need human annotators. You actually don't even need to wait 30 minutes. You can basically get the setup immediately. A third part is that other use cases that are cool and exciting work less well. So agents are cool and exciting. There's a lot of cool stuff around agents. In fact, there was a lot of hype around agents back in April and May. But as people started playing around with it, they realized that there's a lot of use cases that they weren't quite able to solve, right? And so I'm sure people get more excited about agents. We're seeing people branch out from RAG into agent-like stuff, but just in slightly more limited fashion. And as these models get better, like we'll see kind of like step changes in capabilities of agents. But for right now, RAG strikes a nice balance between it solves the use case, it's easy to set up, and also it works like decently well.
Yeah, and it also reduces hallucinations compared to fine-tuning. This is just a quick interruption to remind you to like or leave a 5-star review depending on where you are watching this episode from. It helps the channel a lot, and it's an amazing way to show me if you are enjoying this episode or not. Thank you for watching, and I will let you enjoy the rest of the episode. Well, could you share a bit more on when would you use a fine-tuning of a model rather than RAG or vice versa?
Right. So now the RAG versus fine-tuning debate. I think for the vast majority of developers, if you have some knowledge corpus that you want to understand and you want to basically ask questions over in a search and retrieval setting, you should do RAG. I think fine-tuning has the conceptual capability to do everything that RAG does. Because if you think about it, like, ChatGPT itself is trained over some corpus of data. You ask it about stuff, they'll be able to, regurgitate things and it can answer questions for you, right? It's just practically speaking, there's no magical endpoint right now where you can just fine tune something and it magically learns over your data. Most fine tuning tutorials, if you look on the web, we actually have some fine tuning abstractions, are either very incremental or kind of for limited use cases. And so you can't just run this random process that will fine tune in the background and just automatically memorize every new piece of information that you give it. So that's one. It's just like the kind of UX is not there. And so fine tuning takes more time, it's hard to set up, and also has more incremental use cases. That said, I think fine tuning will just generally do things that RAG can't do, because it can just do some sort of like overall training over the entire data set. This includes like better adherence to any sort of system prompts that you set up. So if you really want to un-RLHF the model and then re-RLHF it with like kind of your own custom instructions, that would be a way to do it, so that it acts more consistently according to your guidelines. You can get it to, for instance, output stuff in certain styles, those types of things. But we have some basic support for fine tuning in LlamaIndex. For instance, we have tutorials on fine tuning Llama 2 or other models for use cases like structured data extraction, text to SQL, those things. We also have used fine tuning to fine tune embeddings for better retrieval performance. That's actually another aspect that people oftentimes miss, is that you should actually probably fine tune the embedding model once you really start to optimize these systems. So they're definitely complementary. It's possible that fine tuning replaces some parts of RAG in the future. We just don't see that yet.
Yeah, you can both optimize the indexing part of your data as well as the querying part. Could you share a bit more on what's the basic of both, and first how much you can improve, but also how you can improve them?
So yeah, the way RAG works, again, is you index some data and add. What does indexing mean? It means you take each document that you're putting into a vector database, and then you embed it, right? So you feed it to an embedding model, and you get back an embedding. This embedding is basically the kind of index on top of this data. And this serves as the thing that you or that you use to do some sort of like top K lookup, right? And so for this embedding, you can fine tune the model to output better embeddings. With a pre-trained model, like you are using like a pre-trained Hugging Face model, for instance, they're typically pre-trained on large amounts of data, but not necessarily specific to your domain. So given the types of questions that you want to ask, if it's very domain specific, that embedding might not actually be optimized so that the relevant context is retrieved for the question you want to ask. So you can actually try fine-tuning this embedding model. There's a variety of ways you can do it. One is if you have the model weights, right? If it's just like a Hugging Face model, you can basically download it, fine-tune it yourself if you know how to write PyTorch. There's also services out there, right, that will kind of do this for you. And we have some abstractions here that try to make it also pretty easy for you to use these different services. This includes, actually, wait, sorry, let me scratch that. I can't think of any off the top of my head that do pure embedding fine tuning. I'm sure they exist. I just can't guarantee that the companies I'm going to say are going to be correct. But the other thing you can do, and this is also a conceptual thing that's pretty interesting, is you can basically take an existing embedding, right? So you don't need to fine tune the base model. You can take an existing embedding, and it can be generated by a black box like OpenAI, Ada, and then you fine tune a transform on top of this embedding, right? To basically transform this embedding representation into another embedding that better models your specific data. So it could be a linear transform, it could be a neural net, but you can basically fine tune an additional adapter model on top of the base model, right? And there's kind of trade-offs, complexities if you fine tune this on the document side versus the query side. But we actually have some basic capabilities in LlamaIndex to let you do that. And we also encourage users to try doing that themselves. But it's a pretty interesting principle, because it's like you can take a frozen model and just fine tune some transform layer on top of it to basically adapt to your data domain a little bit more. On the LLM fine tuning side, I think some core use cases we've seen that we found pretty interesting is you take a weaker model. So for instance, a cheaper but weaker model like a Llama 2, and you try fine tuning it to better output stuff like structured outputs. A lot of RAG use cases we've seen, a lot of users desire kind of like outputting stuff in JSON format. And the best models for outputting stuff in JSON format right now is like GPT-4. So if you're able to fine tune a smaller model to better obey this type of task, then you can basically use a smaller, cheaper model. And so we've that's like a use case that we're pretty interested in. And then some other ones include like being able to just generally distill the prompt and instruction following from a more powerful model like GPT-4 into a smaller model.
And regarding the other sides of the RAG system, for example, chunking, like you need to divide your data, or do you? So what's the importance of chunking size, and also the chunking strategy that you want to take? How do you make this? How do you select which strategy to use, and what size each chunk should have?
That's a good question. I think overall, people don't think enough about the data pipeline for RAG because they use some very standard chunking strategy, and this turns out to be suboptimal, and that's actually why their RAG pipeline is failing. The few variables or parameters you have to think about when you build a chunking strategy is one, the quality of your file parser. So how well are you actually parsing out text from the PDF, right? Let's just say a PDF as an example. There's different types of PDF parsers available. Some are better than others. Some are better or worse at extracting more complex things like, 2-column format, like headers, tables, those things. The next step is chunking. So how do you actually split up the text? Oh, by the way, first of all, why do you actually need to chunk things? And the reason is to just reduce a bigger document into smaller bite-sized context, right? So that one, it doesn't overflow the context window when you do retrieval. Two is it reduces the number of tokens that you use, and as a result, reduces cost and also reduces the speed, the time it takes to actually generate a response. And so, the way you chunk the documents does impact retrieval performance quite a bit. I think generally with kind of like flat chunking, you kind of see like a U-shaped curve in terms of error rate. So if the chunk sizes are too small, you don't actually return enough context so that you can't actually properly answer the question at hand. If the chunk sizes are too big, you start running into attention, loss in the middle problems, as well as like obviously increases in cost and speed. Like sometimes the relevant context is just lost in the middle of a very big chunk, and so the LLM doesn't quite understand what's going on. And so I do think the world will probably move in the direction of bigger and bigger chunk sizes as these models get better. But for now, this is something you have to tune. And the other part here is just like there's something we typically cover in like the advanced retrieval section is like the whole idea of just arbitrarily splitting text by sentences, paragraphs, whatever. It's pretty arbitrary. And so sometimes you just inadvertently start splitting context down the middle. Like you might have a relevant section, and because you pre-split it, the relevant section is now cut in two. And so unless both of those chunks are retrieved, you're not going to have all the context you need to answer a question. So it's because it's kind of arbitrary. I think there's definitely improvements to be made on like how do you better chunk and process these things instead of just doing it by every sentence, paragraph, or by a fixed chunk size. That's something we're actively exploring.
And what's the importance of data quality inside those chunks? Do you have any techniques or to find like irrelevant chunks, or are you curating them, or like because for example, I assume a lot of companies will build RAG systems based on their internal documentation and whatever they have, but lots of things are obsolete or like older versions, and or just it if your chunking is a bit weird, it may have the last sentence embedded, which is completely useless. So how do you curate or improve the chunks? Do you have any insights on post-processing, or do you do anything to improve that?
Yeah, I think that's a good question, and this gets like relatively deep, and honestly, like there's some thoughts off the top of my head, but this is also something just transparently we're like actively working on to try to understand ourselves. There's pieces both on the ingestion as well as the retrieval side that you can do to try to actually improve the final quality of the context that's retrieved, so that your LLM has access to like the most precise, relevant information. On the ingestion side, right, you do need to spend some time picking like a good PDF parser. And so for instance, like unstructured is actually pretty good, I think, for being able to partition out like tables and charts so you can do stuff with it later. And also some PDF parsers are pretty bad in that they just like, you can tell like the text itself is just like very messily formatted. The other piece is I would probably spend just, some basic effort setting up an evaluation benchmark and seeing which chunk sizes actually lead to the best generation performance, right? If, for instance, your kind of a chunk size is a parameter that you can tune. In terms of overall splitting strategies, there's different splitting strategies. There's like sentence splitting, paragraph splitting. If you can, I try to preserve like sections so that like contiguous sections aren't split in half. So for instance, if you're splitting like a markdown file, it makes more sense for you to like keep a contiguous section versus just like have some overlap between two sections. And we have actually a markdown text splitter that tries to preserve that to the best of our ability. And then the other piece here is there's more kind of like data improvements you can add on top of the chunks themselves. And actually, there's a few that I'll talk about. One is metadata. This is actually really important because if you just have the raw text chunk, it's not contextualized. The embedding of that text chunk or the LLM will not really know where this text chunk falls in relation to anything else that's retrieved. Even adding stuff like the file name, a short summary, or a kind of like a higher level abstractive summary of like what this thing is about can help retrieval, metadata filtering, and a variety of other things. There's more stuff here too, but this is just like kind of some aspects that users consider on the ingestion side. On the retrieval side, I would typically say, there are a lot of this draws from traditional retrieval practices of how do you retrieve the most relevant context given the query. Part of this, again, is the data quality that we just talked about. The other is the algorithm that you have. Typically, for most production retrieval pipelines that we've seen, even independent of the LLM, you have some like two-stage pass where you first do some sort of like top K retrieval via embeddings. And then the second stage is you might want to do some re-ranking, right? And so fusion between like different retrieve results. And even actually before that, before you actually launch a query, you might want to do some sort of like query rewriting or decomposition to basically decompose a complex question into smaller ones. A general reference advanced architecture, right? Like I'm not sure if this is the most general form available, but certainly I have like decent confidence I'll probably do better than the basic stuff. Is start off with a query, decompose it into subqueries if you can over like different tools. And so LlamaIndex does have like a bunch of abstractions to help you do that. Decompose it into subqueries. Now for each underlying like smaller query, execute it against some sort of retriever. And you can have, for instance, like multiple retrievers, like one doing hybrid search, one doing keyword search. And it's actually okay. It's called like ensemble retrieval, right? So you have a bunch of candidate chunks. And then this is your first stage pass. So all of a sudden you have a bunch of like chunks, all from like different retrievers. Some of them might be duplicates. And then you do like re-ranking, filtering. That's like the second stage piece where you actually try to filter out for the most relevant ones. This is typically using a more powerful model than like just pure embedding model. Yeah. Cohere, for instance, has like a re-ranker. You can use like the LLM itself to re-rank stuff. You can use a cross-encoder model. There's a variety of these are publicly available. And you finally get back the relevant context they can feed to the language model. So this is just an example architecture, right? But these are like general practices that people should think about.
Yeah, super interesting. Would you have any insights on, you mentioned the OpenAI Dev Day and now evaluation. So I know that in the Dev Day, they mentioned that they were using RAGAS to build an evaluation pipeline. Is it the one you would also recommend, or how would you evaluate any new RAG system?
Yeah, RAGAS is great. I should play around with it more in depth. But I know the kind of project creators, it's a great framework. We also have some of our own eval modules, but they're very basic. And so we're trying to look at both improving them, but also integrating more with kind of these third-party providers. I can maybe talk about conceptually what evals consists of, because we also just did a deeplearning.ai course with Triera actually on like building and evaluating advanced RAG applications, which all of you should check out if you haven't. In terms of evaluating RAG just conceptually, there's a few key areas. One is, you have this question that's asked, and then you get this like predicted response. And you also have the retrieve context, right? And if you have like a ground truth answer or ground truth retrieve context, you can measure both generation as well as retrieval metrics based on how close this reference answer or this predicted answer is to a reference answer, as well as how good the predicted context is to the retrieved like ground truth context. And then that's a basic metric. It's like a correctness metric. And then there's also stuff beyond that. So, you can actually measure the predicted response relative to the context. This is called like faithfulness. And so if the response actually you found isn't actually generated from the context that's retrieved, this means the LLM is probably hallucinating, right? You can also measure whether or not the response one adheres to guidelines like structured outputs, those things, but also whether the response answers the question, right? And this is like relevance. Does this actually answer the question at hand? So there's both retrieval as well as like generation metrics that you can define. And then you can also have like define metrics in a label free or with label setting. And all of this, by the way, for retrieval metrics, you can just compute standard ranking metrics. So stuff like MDCG, MR, that type of stuff. For comparing the quality of generated responses, what a lot of users do is they typically use an L1, right? And so you use like GPT-4 as a human judge, and you can basically judge whether or not the quality of this response matches the quality of another response.
Awesome. Do you think RAG is the future of memory-based language models, or will like GPT-7 be good enough to just first answer all your questions? But I understand that there are some private data, so there will necessarily be something to do with this kind of use case. But will it become like super easy to quickly fine tune a model? What are your thoughts on the future of LLMs? Is it like basically where I'm trying to go is, do you think LLMs will become powerful and easy enough to use that you will only require them, or is it still like just a small part of a bigger product that will all make it work much better?
Yeah, I mean, I think there's a few points in here. And I think some of these are actually pretty interesting to think about. And some of these I don't actually have the right answers for. We can mostly speculate. And some of these are things that obviously I probably hope to be more true than others, because then, we're building a framework that's kind of like at the orchestration side. So one is whether the current form factor of RAG will last. To be honest, like probably not. In fact, like you can already see this evolving. Like, I mean, okay, by the way, what is the form factor of RAG? Like, and by that assumption, I mean specifically taking in a bunch of text, chunking it up using some like naive like text splitter, and then doing like top K retrieval, right? Like part of the things that we've invested in this entire past few months is to move beyond that, because that basic stuff, like already people find doesn't quite work as well as people want. So I think that like just even conceptually, just in terms of the reference like RAG architecture, that the best practices around that will probably evolve. As to whether or not a lot of this retrieval will get absorbed into the model, I think retrieval itself will probably be absorbed into the model in some way. Like you'll probably start to see longer context windows, even infinite ones, where somehow like basically like the transformers architecture will somehow leverage like top K lookup or a vector database under the hood. This started with stuff like DeepMind Retro last year, stuff like the Memorizing Transformers paper. There will be kind of probably interesting developments on the model space. I don't think, however, that just from my own gut intuitions of like the ML research, that this will basically just obviate the need to do any sort of indexing storage of data on the developer side, because like just being able to kind of index arbitrary amounts of data is still generally a pretty hard problem. And I think I think like the amount of compute and kind of like the cost you would need to actually solve this will still probably be quite high. I think there is a world where AI gets better. I think or it gets much better very quickly. I think everyone agrees that AI will get better at longer context windows, understanding things much more cheaply and quickly, and also the fine tuning aspect. Being able to just like fine tune on arbitrary amounts of new data. I think the question is how like compute constrained we are, right, and kind of like cost constrained. And I think it's a very exciting feature. Like I think I personally think I'm probably like somewhere in the middle, like in between. People think like this like GPT-4 is the peak, versus like people think like AGI is going to happen in the next like 3 months. And part of this is also just like practically speaking, I think most people are still having trouble accessing compute. To be honest. And I think also just at the kind of like looking ahead at like future developments of these models, the extremes still seem a little bit far away.
Yeah, I do agree. And regarding maybe more specifically towards a skill that is currently being required to develop such LLMs based models, approaches, systems, is right now like the biggest skills that I believe I'm not hearing a lot about, but prompt engineering, which was extremely popular like a few months ago, and now I think is way less popular maybe. But do you think prompt engineering is there to stay, or will LLMs become like better and better to understand the English language or other languages to just easily use them? Like, is it still a promising skill to learn for any future LLM developer or even users?
Yeah, I think for that, it kind of depends what you mean by prompt engineering. If you define prompt engineering as literally fiddling around with like the F string and adding like some random brackets and trying to, like add some special character or like stop token or something so that you can generate things. Yeah, I think that will probably go away, right? But I actually think the need for prompting in general will not, and I'm kind of defining this in a very general sense, will either stay the same or actually even go up as time goes on. What do I mean by this? I mean, if you think about it, RAG is basically prompt engineering because you're basically figuring out a way to put context into the prompt. Yeah. It's just a programmatic way of prompt engineering. If we think RAG will get better, then that we could see that as a way of prompt engineering. It's a way of prompting so that you actually get back some context. Any sort of higher level abstractions you build on top of LLMs require some user description of a task. And so no matter how much the LLM powered agent under the hood will solve stuff for you, at the high level, you still need to tell it a task to solve, and it needs to be able to solve that for you. And so I do think this idea of prompting will probably continue to be a need, because like even if you're abstracting away a lot of the lower level needs to specifically fiddle around with like a specific word, and even with stuff like the Assistance API, the input interface to that stuff is still English, right?
Yeah.
And so the thing you need to do to interact with it is still with English. And so the need for English as an input is still going to exist, right?
But do you think, similar question with transformers and the basics to know, do you think in the user end, they need to understand like prompting and be a better prompter, or should they not even look into that and not learn anything about that?
Yeah, I don't think I actually okay. So I don't think the prompt engineering category itself will necessarily last as like a differentiating like career title, if that makes sense. But I do think the ability to use AI will continue to be a differentiator, because no matter how high these abstractions are, you need to figure out how to best take advantage of them to help you, basically, right? Like people that are able to learn how to use ChatGPT effectively get like 30% efficiency boost versus people that don't know how to use ChatGPT. And so I do think that part will still be important, and might actually be more important as these models get better.
Yeah, I've recently spoke with a product manager at Google, and she said that like the skills she is now looking for is communication, but mostly communication with like language models, because you can pretty much do almost anything if you are good with using it. Just like back in the days, if you are good with Google, you can find on Stack Overflow how to code anything. Now it's just like Stack Overflow on steroids.
Yeah, exactly.
And I have one last question for you, which is one I often ask, but now it's more personally for you. What do you use AI for? Do you use ChatGPT or GitHub Copilot or any generative AI? What do you use it for?
Yeah, I use ChatGPT a lot, actually. I use Copilot. I've been meaning to try out some other stuff like Cursor, like basically coding assistant tools.
Yeah.
On our own Discord, we use Kappa AI for documentation handling. We use Mendable on our search, and we also use DosuBot on our GitHub. And so there are ways, and there's some like kinks and like rough edges, but like like they're good. Like they've objectively saved us time, right, in terms of actually like manually like going in and trying to like save answer issues or respond to questions, like those types of things. I've been meaning to try out more tools. I actually use LlamaIndex like itself, right, to try to like process like a a lease agreement, and to to try to like answer questions over it. So that was fun. But yeah, I'm looking forward to like dogfooding it a bit more.
For coding, when do you use, or why do you use Copilot versus ChatGPT, or when would you use each?
Oh, okay. Yeah. So, I mean, Copilot's just Copilot. I mean, it's just there, right? I think if it's just there, I'm just going to use it. In fact, it's just there without actually me even needing to toggle a bar. So I think that's a thing. Like it just shows up and you just tap complete it. I think that's actually a pretty important UX. ChatGPT, I've started using it because sometimes I don't find answers on Google. And sometimes the question I ask is somewhat complex and I need it to like kind of basically synthesize something from like disparate sources of knowledge. And it actually does a pretty good job sometimes. Yeah.
But what I meant is that on my end, I prefer to use ChatGPT for coding over Copilot. And so I just wonder,
interesting.
why I assume you are using Copilot because of UX, as you said. And I think that's also how AI will become more and more popular to the general public is by integrating it like easily to use in all current applications people are using. But have you tried coding or using ChatGPT as a coding assistant? And if so, like, why do you prefer Copilot? Is it purely for UX, or also results are better? Or
oh no, I mean I do use ChatGPT to help with like kind of debugging, and I also help it to look up stuff that I forgot. Like for instance, like pydantic, like method definition on to do a certain operation. I actually do that. I think the reason I use Copilot more is just like it's right there, like a code in VS Code, and also I'm more familiar with Python. So actually, I think like when I was trying to learn or code a little bit in TypeScript, or even kind of like do some stuff with Streamlit, like for instance, right? I use ChatGPT a bit more to learn something new. But I think for stuff I'm more familiar with, it's easier to integrate with my existing workflow.
Yeah, that's a perfect answer. I completely agree with using ChatGPT if you are learning, and Copilot might be better for productivity and for just like coding faster. That's like perfectly makes sense. Amazing. Is there anything you'd like to share, or like where can people learn more from both you or LlamaIndex? If you want to share anything about the company or yourself, please feel free.
For sure. Yeah. I mean, I think we covered most of the basics. The only two things I'll say is one, I think we're investing a lot more in kind of not just the advanced like RAG techniques and those things, like on the core tech side, but also a lot more on like full stack kind of AI application development. And so if you have suggestions, feedback, we've launched products like Freight Llama, which is like Freight React app, but for AI engineers. We've launched like Chat LlamaIndex, SEC Insights, basically full stack application demonstrations of how AI UXs can be created. And then the other piece I'll say is, if you're an enterprise, like we're working at enterprise, we're always interested in seeing how you're adopting LLMs in like different use cases. So we're hosting office hours basically. So DM me and would love to chat and learn more about your use cases, pain points, those things.
Super cool. I'm really excited to see all the future updates coming, and I'm also using LlamaIndex, and we are going to use it more for an upcoming project at Towards AI. So super excited about that. But yeah, thank you very much for your time, your insights. It was super cool to dive a bit more about RAG and to have an expert on this topic to talk with. I highly appreciate you taking the time, and yeah, thanks again for this amazing discussion.
Thanks for having me.